Hey, mathletes. We're checking out 8, 4, factoring with a constant in front. I know you're stoked. So, let's check this out. All that's new with this is adding a constant in front, and it really screws things up. Let's be honest. So, we're going to reverse engineer this. So, check out, when we have some new constants here, we're used to just factoring like x plus 2 and x plus 5, right? When you have new constants here, it messes things up because you get 3x times 2x and you get 6x squared. We're not used to having this here, right? And then when you multiply 3x and 5, you get 15x, and 2x and 2x, you get 4x, and 2 and 5, you get 10. Okay, great. And when you combine those, you add up the 15 and the 4. Great, easy. So where did this coefficient come from, this 6? Well, it came from the product of this and this. All we're looking at is patterns right now. We're just looking at patterns. Where did this come from, this 10? Well, it came from these products. Yeah? So what about this weird middle one? Right? Well, if you take a look at it, it's the sum of the outer and inner products. So let's think about that real quick. It's the sum of the outer and inner products. So 3 and 5, 3 times 5 is 15, and that's the product of these two, and the product of the inner ones, 2 and 4, is 4. Sorry, 2 and 2 is 4. And then we are adding them up. We're finding the sum. So add them. 15 and 4, 19. Bing. Cool? So let's look at this in a generic example, right? If we have some number x plus r, some number x plus t, the product of these two is going to be your A. The product of your R and T is going to be your C. But B is kind of a conglomerate. Many factors affect it. It's the product of T and G plus R and H. Yeah? And the hard part about when you see a trinomial with A, the hard part is making sure B is correct. So we're going to try a couple out. Now, the one way to do it is called the guess and check method. Very scientific, I know. But basically, what we're trying to find out is what can we put in here, here, and here, right? We know how to find these last terms, right? It's probably it's a product of 12, so it's either 1 and 12, or it's 2 and 6, or it's 3 and 4, right? So I know that one of these sets is going to go in here. Yeah? The problem is what to put in here. Now, we've kind of been saved because this is a fairly easy one. We know that these two are products of these two are going to have a result of 2. So one of them's got to be 2, and the other one's got to be 1. That's pretty much all that can be here. And we're just starting easy that way. So the guess and check method is just that. We guess what it might be, try one of these in here and check. So let's start with this one. Usually the middle ones work well. I don't think it's going to be this one because we're going to have to multiply by 2 or by 1. So I'm going to stick in a 2 and a 6. And let's try that. 2x times 1x is this, yes. 2x times 6 is 12x. When we did this, 2x times 6. And 2 times 1x is 2x. And if you sum those, that adds to 14. So those don't work. Yeah? These don't go in there. All right. So let's try a different one. These didn't work. Let's try 3 and 4. So let's stick 3 in here. Let's stick 4 in here. And let's try it now. 2x times 4 is 8x. And 3 times 1x is 3x. And if you sum them, 8, 9, 10, 11, you get 11x, right? So the middle term is what makes or breaks it, so I usually aim for that first. Because if you set it up right, you know that when you multiply in your 2 and your 2x and 1x, you really get your 2x back that you're hoping for. 2x squared. This is positive 11x, what we just found, and then your 3 and your 4 leaves you with 12, and so our check step, yeah, is back. So this is the guess and check method, and you'll get better at it as you use it, but there's a more systematic way to find out, so you don't have to just guess and check. We know that this product comes from this and this, so these two things, this multiplied by this gives us our 2. So let's find the products of that. Well, it could be 1 and 2. 1 and 2 is basically all we've got. Yeah? So write down all the products. Yeah? And then think about factors of 12. What sort of things fit into here? This times this need to be 12. Well, there's more factors there. That's why this is written out so many times, because we have 1 and 12, 12 and 1, 2 and 6, 6 and 2, 3 and 4, 4 and 3, right? And we want to know when the inner and outer products are the same. The outer products are these two, and the inner products are these two, right? So we want to know when the inner and outer products sum to 11. So let's think about it. 1 and 12, 1 times 12 plus 2 times 1, do they sum to 11? Well, here, let's see. 12 plus 2 more, 14. No. What about here? 1 times 1 plus 2 times 12. Well, 1 times 24 is 25. No. And we keep trying it. 1 times 6 is 6. 2 times 2 is 4. Equals 10. Boom, boom, boom. We keep trying it. And eventually, we find one where 1 times 3, right, is 3. And 2 times 4 is 8. And 3 and 8, yeah, is 11. So we know we're going to use these sets. We know we're going to use 1 and 2 and 4 and 3. Okay? So we know that 1 and 2 are going to go in here, and 4 and 3 are going to go in here. Yeah, in that order. 1 times 2x is 2x squared. 1 times 3 is 3. 1 times 3x is 1x times 3 is 3x. 4 times 2x is 8x. And 4 times 3 is 12. And if we sum those x's, we get 11x. Bingo. Okay? So, you can try that here. I don't care which method you use. You might have to go back and review them, but try it out and stop your screen now. Okay. So this one's fairly easy because we have we know one of our a is 2, and so we know one's got to be 2 in front of x, and one's got to be 1. Yeah. The hard part is what is going to sum to this. We know they're both positives, so let's think about what sort of things multiply to 21. Well, 21 is good products of 3 and 7. So this was kind of a nice one because these are kind of the only ones that multiply to 21. So I might just guess and check and figure out which way we can put them in there. I'm just going to throw them in at random, 7 and 3. So let's try this. I've set it up so I know this term will come out, and I'm not worried about it. I'm looking that we can find this term. So 2x times 3x is 6x, and 7 times 1x is 7x, and 6 and 7 is 13 and not 17x. So no, didn't do it right. So let's take these out. But instead of throwing these away, let's just flip them. So we had 7 and 3. Let's do the same idea, but let's do 3 and 7. Because each one gets multiplied by a different piece. The 7 will get multiplied by the 2, and the 3 will get multiplied by the 1 now. So here we have 2 and 7. You get 14x. And 3 and x. Oh, and that is 17. Yay! Bing! So we know now when we do 2x times 1x, we get 2x squared. And 3 and 7 is 21. And when we add up these two, you really get 17x plus 21. And we've got our 2x squared out in front. Awesome. So that's exactly what we're looking for. So this is our factored form of this. Okay, brethren. Yay. All right. Hopefully you've tried this. If you haven't, it may be a little tougher. But we're looking for things that multiply to 4 and as your products on the outside, and things that multiply to 6 as products on the inside. So this may take you a little longer. But for the sake of time, here's your answer. Yeah, 3x plus 4 times 2x plus 1. Done. Cool. Things get a little uglier when you have negative b. Here 14 is negative. So you know that there's going to be negatives involved in the answer. So here, this is another table. Factors of 5 are 1 and 5, 1 and 5, 1 and 5. This is nice. We got lucky because we only have one set. So we can find the factors of 8. Well, negative 1 and negative 8, negative 8 and negative 1, negative 2 and negative 4. Those are the only things that multiply to a positive 8. Yeah? But we're looking for negative 14. So we're looking for things that add up. We're looking for things that add up to negative 14. So 1 times 8 is negative, 1 times negative 8 is negative 8. 5 times negative 1 is negative 5. And if you add them up, you get negative 13, and not what we're looking for. Do the same thing with the second column. We get negative 41, not what we're looking for. Do the same with the third. 1 times negative 4 is negative 4. 5 times negative 2 is negative 10, and when you add them up, you do get negative 14. And so we can just stick these in here as 1 and 5, yeah, and then 2 and 4, in that order, yeah? You can try that with this group practice, and stop the clock now. All right, so let's try this out. We know that 16 can be just a couple of things, probably 4 and 4, negative 4 and negative 4, or 2 and 8, 8, negative 2 and negative 8, right? So those are a couple of things that those could be. One of these by the x's has to be a 3, because that's the only way to multiply to 3x squared. So we know that 1 has to be a 3 and 1 has to be an x. So our first term gets this, and these are going to be one of these sets. Now I'm not sure which. I think I'm going to go with one of these to start with, because I know that 4 times 3 maybe a little bit big, but we'll try it. So I'm going to try my 2 here and my 8 here. These are negative. This is negative, and it's fairly big, so I'm going to put 2 negatives in it and try it out. So 3x times negative 2 is negative 6x, and 8 times negative x is negative 8x. And this is negative 14x, so this isn't working. We could flip it, I suppose, and try 2 and 8. 2 and 8. But then 3 times negative 8 is too big already. So I might scrap this idea. Let's try something different. Let's try our 4 and our 4. Yeah? So let's try 4 and 4. Well, 3x times negative 4 is negative 12x, and negative 4 times x is negative 4x, and negative 12 and negative 4x is negative 16. So I like this setup. So when we do 3x times 1x, we get 3x squared. And when we do negative 4 times negative 4, we get 16. And so now we've got 3x squared minus 16x plus 16. Woohoo! And our brains are kind of smoldering right now. But I think that's what we got. Bingo. So it doesn't matter which order you put the binomials in. Cool. And one last one. Trying to have a positive a and a negative c, right? If this is negative c, one of the factors needs to be negative. So let's find the factors of 4. There's factors of 4, 1 and 4. I think just for efficiency, we didn't put 2 and 2 in. Factors of negative 2, there's a couple. And then you can still make the table work. You can find that 1 and negative 1 is negative 1, and 4 and 2 is 8. And so negative 1 plus 8 is 7, which is the middle term we're going for. So there's our factored form. Cool. You may run across some of these that have a negative a term. If they have a negative a term, factor the a out. It's kind of like saying we had negative 1 and we multiplied negative 1 into each term. Okay? So factor it out. If this was something like was a plus, yeah, when you factor it out, when you factor this negative 1 out, this will become positive, this will become positive, and our plus will become negative. Okay? So just watch your terms, watch your signs. So factor 1 out, and then leave the negative 1 outside and factor the new trinomial. Yeah, so you're going to factor this and kind of forget about him for a while. Great. So try it out. So you should stop the video and try it now. All right. So we should have gotten 3x minus 1 and 2x plus 3. Because if you factor this, you'll end up with 6x squared. 3x times 2x is 6x squared. You end up with, so that's 6x squared. You end up with 3x times 3x, which is 9x. You end up with negative 1 times 2, which is negative 2x. And you end up with negative 1 times 3, which is negative 3. These sum to positive 7, positive 7x. Got negative 3 at the end, and 6x squared, and we got our check, right? This guy has a negative on everything, so we should have factored out a negative 1, and then had negative 1 times 3x squared plus 17x plus 10. And when we factor that, we get this guy. And you can check it just by going 3x squared, yup. 15x and 2 more x, 17x, yup. 2 and 5, 10, yes. All right, so I hope that your brains are smoking a little bit right now, and that's okay, because it's algebra, and you're doing awesome. Okay, ciao.